unit circle, we need to know some values, or actually recall some values, so that we can graph the parent functions for today. So just like with any of the other parent functions, like quadratic, absolute value, you need to know where does that parent function start, and how do you draw it? What does it look like? So in order to do the trig graph for today, we'll have to recall these values off of the unit circle. So starting at 0 degrees, what is the ordered pair at 0 degrees? 1, 0. What about at 90 degrees? 0, 1. What about at pi?
-1, 0.
-1, 0. And 3 pi over 2.
0,
0, -1. And remember, these are cosine, sine ordered pairs. So the first value is the cosine value. Second value in the ordered pair is the sine value. Now for pi over 4, again, we're just doing increments of pi over 4. So for pi over 4, what's the cosine? Square root of 2 over 2. Square root of 2 over 2. And the remaining will also be square root of 2 over 2. And square root of 2 over 2. So we have to remember in which quadrants is sine and cosine positive or negative. So I know in quadrant 1, sine and cosine are both positive. In quadrant 3, sine and cosine are both negative. And in quadrant 2, sine is positive, cosine is negative. Quadrant 4, we reverse that. The sine would be negative, and the cosine would be positive. So back to this ordered pair over here for 3 pi over 4. It's the cosine that needs to be negative. So make sure that first value is negative. So this one should be negative square root of 2 over 2. Now 5 pi over 4, down here in quadrant 3. Same thing. Square root of 2 over 2. Square root of 2 over 2. But which one has to be negative? Both of them. In quadrant 3, sine and cosine are both negative. Sine is negative. Cosine is negative. And for 7 pi over 4, down here in quadrant 4, again, we're using square root of 2 over 2 and square root of 2 over 2 for our reference angles. But which one should be negative? Sine. So cosine is positive, but that second one, the sine value, has to be negative. Now we're going to use those values to graph the parent function. And the first one we're going to look at is the sine parent function. And sine is always the second value of the ordered pair. So we're going to start at 0 degrees. So at 0 degrees, what is the sine? 0. So our first ordered pair will be 0, 0. Next one, if this is pi over 2, what is this marking right here? It's smaller than pi over 2, and it's half of pi over 2, which would be pi over 4. So that x-axis is being scaled by pi over 4. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So the x-axis is scaled by pi over 4. So that next value is for pi over 4. And looking at pi over 4, the sine value would be the second value in the ordered pair. Now I need to approximate that. Square root of 2 divided by 2, for graphing purposes, we need to figure out what that value is approximately. So square root of 2 divided by 2 is approximately what? Yeah, it's about 0.7. So at pi over 4, put a point at 0.7. So pi over 4 goes up to 0.7, which would be about right here. And pi over 2. What is the sign for pi over 2? 1. So pi over 2 goes up to 1. And that's 1 pi over 4, 2 pi over 4. What's this next one? 3 pi over 4. And at 3 pi over 4, the sign is about what? About 0.7. So at 3 pi over 4 is about 0.7. And pi, what is the sign of pi? 0. So at pi negative 0.7. And for 3 pi over 2, what is the sign for 3 pi over 2? Negative 1. So 3 pi over 2 drops down to negative 1. And this next one would be 7 pi over 4. And what's the sign for 7 pi over 4? Negative 0.7. And 2 pi, we're back where we started, which would be at 0. And that is called a period. That is one full cycle of the sine function. So let me connect the dots. And this is a curve. It's a sine curve, so it needs to be rounded. And put an arrow showing you it keeps going upward. So that is one complete cycle, and one complete cycle is called the period. So the period of sine starts at 0 and it goes to 2 pi. So how many units long is that period length? Starts at 0, ends at 2 pi. The period is 2 pi. It goes from 0 to 2 pi. That's how long it takes to make one complete cycle. Now, when we draw the sine parent function, we normally don't use the increments of pi over 4. We just use the peaks. And let me mark those in orange. So we started at 0. No, let me do green. We started at 0. Then at pi over 2, it goes up to 1. That's the maximum. So the highest the sine parent function goes up to is 1. And down here, this is pi is at 0. 3 pi over 2 is the minimum value of negative 1, because that's the lowest the parent function goes. And then we go to 2 pi, which is back to 0. So notice in order to make the sine function, a piece of the graph, this first piece, is called concave down, because if you think about a parabola, which way is that pointing? Down. And this part is called concave what? Up, because if it were a parabola, its lines would be pointing up. So a sine function is complete when you have one section that is concave down and one section that would be concave up. And it's going to alternate. So if this is concave down, the next part, if this is concave up, the next section needs to be concave down, and then the next section would have to be concave up, followed by concave down. So it alternates. So now we're going to complete one more cycle. So to complete one more cycle, here's the middle of the period, right there at pi. And at 2 pi, it will complete one more cycle. But if this one is concave down, this next one should be concave up. So at negative pi over 2, the y value is negative 1. And I can see that on my unit circle. If my radian measure is negative, that means we rotate clockwise. So negative pi over 2 would be from the initial side on the positive x-axis down here to what would be normally positive 3 pi over 2. So positive 3 pi over 2 is the same as negative pi over 2. So the y value is negative 1. And if this is concave up, the next piece of the graph has to be what? Concave down. So it has to reach the maximum of 1. And put an arrow showing you it keeps doing that cyclic pattern. Concave up, concave down, concave up, concave down. Now we have to fill in the domain and the range. So the domain, it keeps going to the left, it keeps going to the right, so what's the domain? All real numbers. So you can write it with that bolded R, or you can write it in interval notation. Either one, whichever is your preference. Whichever one is your preference. Now the range. Is the range all real numbers? No. What is the lowest it can go? Negative 1. And what's the highest the y value can go? Positive 1. So we're using interval notation. Both of those values are inclusive. We have points at negative 1. We also have points on that graph at positive 1. Okay, so there's the sine parent function. Memorize what it looks like. So it starts at the origin, goes up, comes back to the x-axis, comes down, back to the x-axis. And again, the period length is 2 pi. So halfway up, you should have one hill, and for the second half, you should have the other hill. Now after sine, we have cosine. So for the cosine, going back to my unit circle, cosine is going to be the first value in each of those ordered pairs. So looking at 0, what is the cosine of 0? Here's 0 right here. Cosine is what? 1. So at 0, it goes up to 1. For pi over 4, what's the cosine for pi over 4? Cosine for pi over 4 would be about 0.7. So pi over 4 is at 0.7. Pi over 2, what's the cosine for pi over 2? 0. So pi over 2 is at 0. 3 pi over 4. What's the cosine for 3 pi over 4? Negative 0.7 is correct. What is the cosine for pi? Negative 1. And what's the cosine for 5 pi over 4? Negative 0.7. And what's the cosine for 3 pi over 2? 0. What's the cosine for 7 pi over 4? 0.7. And what's the cosine for 2 pi? 1. And there is one complete cycle or period for the cosine parent function. And put an arrow to the right showing again. We keep going. And we're going to complete one more cycle over here on the negative x-axis. But the period length, it took 2 pi to make one complete cycle. So from 0 to 2 pi, it made one complete cycle. We started at 1, and at 2 pi, we ended at 1. So it took 2 pi units to complete one full cycle. Now the next part. Before we do the domain range, we'll need to complete one more cycle. So this would be negative pi over 4. Negative pi over 4 means that we rotate clockwise. So for negative pi over 4, what's the cosine? 0.7. So for negative pi over 4, it's 0.7. And negative pi over 2, yes, would be 0. And that actually will help us a lot. Because the cosine function is very similar to the sine function. Here, this part is concave down. This is concave up. This would be concave down. So we continue the pattern. And let's see. So negative 3 pi over 4 would be at negative 0.7. Negative pi is at negative 1. Negative 5 pi over 4 is back at negative 0.7. Negative 3 pi over 2 is on the x-axis. Negative 7 pi over 4 is at positive 0.7. And negative 2 pi gets us back to 1. And put an arrow showing you we keep doing that pattern. The up, down, up, down, up, down. So what's the domain? All real numbers. You can use that bolded R, or you could use interval notation, either one. And the range, what's the range? Negative 1 to positive 1, just like the sine function. Now, looking at the graph of the cosine function, how is it similar to the sine function? Yeah, it alternates. It alternates. We have the up, down with a concavity. But what's the main difference between cosine and sine here in function? Well, it's not longer because they both keep going. Where does the sine function start? At 0. Does this one start at 0? No. So the starting point has just been translated to the left pi over 2 units. So the sine and cosine, they both have the same maximum of positive 1 and the same minimum of negative 1. It's just been translated to the left pi over 2 units. Okay, parent function number 3 would be the tangent function. Now, using our unit circle to find the tangent function, tangent is sine divided by cosine. So to calculate the tangent, it's sine divided by cosine. So sine divided by cosine. So going back to my unit circle. Sine divided by cosine. So starting with 0. Sine divided by cosine would be 0 divided by 1. So what would that tangent be? 0. For pi over 4, sine divided by cosine would be square root of 2 over 2 divided by square root of 2 over 2, which is equal to 1. Up here at pi over 2, this would be 1 divided by 0, which is undefined. At 3 pi over 4, this would be square root of 2 over 2 divided by negative square root of 2 over 2, which would be negative 1. Sine divided by cosine, this would be 0 divided by negative 1, which would be 0. And what would this one be? Positive 1. What would this one be? Undefined. And what would this one be? Yes, negative 1. Now, using those values, wherever you see undefined, you need to draw in a vertical asymptote. So where would we have vertical asymptote? Where is it undefined? At what angle? 90 and 270. And in radians, what would that be? Yeah, pi over 2. And 3 pi over 2. Now, filling in the points in between, for pi, what is the tangent of pi? 0. And this would be 3 pi over 4, so what's the tangent for 3 pi over 4? Negative 1. And this would be 5 pi over 4, and what's the tangent for 5 pi over 4? Positive 1. So between your vertical asymptotes, you're either going to have a quadratic function or a cubic function. And what does it look like we'll have between those two vertical asymptotes? Cubic. The left arm points down, and the right arm points up. And that is one complete cycle of the tangent parent function. So how many units long is this? We went from pi over 2 to 3 pi over 2. What do you add to pi over 2 to get to 3 pi over 2? 2 pi over 2 and 2 pi over 2 simplifies to what? Pi. So the period for sine and cosine are both 2 pi, but for tangent, the period is shrunk in half. It's only pi units. Now we need to complete more cycles. So if I go to the left, where would the next vertical asymptote be? Negative pi over 2. And where would the next vertical asymptote be? negative 3 pi over 2. So drawing those two vertical asymptotes. And just draw in these 3 points. So in the middle, between the two vertical asymptotes, that middle point should be on the x-axis. So find the middle between the asymptotes. That middle point needs to fall on the x-axis. And the left point is down. The right point is up. The left point is down. Right point is up. The left arm points down. Right arm points up. And when you connect these, make sure your cubic function goes all the way to the top and bottom of the graph. So extend those arms all the way to the top and bottom. Now, do I have enough room to do another complete cycle or period? No. But do I still have more room on the graph? Yes. If you still have more room on the graph, you need to fill it up completely. So if you can do a partial cycle, you need to do a partial cycle. So over here at 2 pi, that would be the middle point. So at 2 pi, it needs to be on the x-axis, and the left point is down. Now I don't have enough room to do the right point, so when I connect these, I'll just have 2 points to connect, and I'll put an arrow showing it would keep going. Now I need to do a similar process over here on the left-most side, and negative 2 pi would be the center point, so negative 2 pi will be on the x-axis, and this time it's the right point that will go up. The right point is up when connected. And connect that point, or those 2 points, for our next partial cycle of the tangent parent function. Now when it comes to memorizing the tangent parent function, I usually just look right here at this middle period, and notice that its central point is at the origin, left arm is down, right arm is up, and then you have vertical asymptotes at plus or minus pi over 2. So our domain, now it keeps going left and keeps going right, but can we ever touch these vertical asymptotes? No. So the domain is almost all real numbers because they keep going to the left and keep going to the right. Except, so this comma means except, so it's all real numbers except x cannot equal. Now we have to list our vertical asymptotes. So do I want to list pi over 2, 3 pi over 2? Is the last one at 3 pi over 2? No, I have another one at 5 pi over 2, 7 pi over 2, 9 pi over 2. Do you want to list all of those? No. So we're going to write these using what's called a recursive formula. So we're going to start with the first one. So x cannot equal, our first vertical asymptote we drew was at pi over 2. So x cannot equal pi over 2. So pi over 2 right here was where we had the first vertical asymptote. But is that the only vertical asymptote? No, because if I add, what do I have to add to pi over 2 to get to 3 pi over 2? Pi. So plus pi, but if I just put pi, that only gets me to 3 pi over 2. But is that the only 2? No, but it would keep going. We would have 3 pi over 2, 5 pi over 2, 7 pi over 2. So to show it would keep going, we write it as plus k pi. And then we have to define k, where k is an element of the integers. So we use that bolded z to represent the integers. And you learned that back in your Algebra 1 pre-AP days. But it's been a while since we've had Algebra 1. Now remember, the integers are the whole numbers and the opposites. So have 0, 1, 2, 3, negative 1, negative 2, negative 3, etc. So what if I subtracted 1? What if k were negative 1? What would the next vertical asymptote be? This would be pi over 2 minus pi, which would be pi over 2 minus 2 pi over 2. And what does that equal? Negative pi over 2. And do we have a vertical asymptote at negative pi over 2? Yes. So that's why k has to be an element of the integers, because to get the asymptotes to the right of pi over 2, you would need to add pi. But if I want the asymptotes that are to the left of pi over 2, we would have to subtract. So that's why we have to use the integers, so that we have positive values for k as well as negative values for k. Now the range. The range is a lot less complicated. And what is the range? The y values keep going down, they keep going up, so what's the range? All real numbers. Or if you want to do integral notation, you can. Negative pi to positive pi. Not negative pi, negative infinity to positive infinity. I was looking down here. Okay. So we did sine, we did cosine, we did tangent. So those are the three main ones. Now we are going to do the reciprocal for those three. So cosecant of x is the reciprocal for which one? Sine. So cosecant, another way to write cosecant would be 1 divided by sine. So cosecant is 1 divided by sine. So to find the cosecant values, we need to find the sine values. And then that sine value needs to be divided. Okay, so let's go ahead and start dividing. So to find all of these cosecants, first let me erase everything in blue over here. Well, not everything. I'm going to erase all these tangents. Okay, so I just told you that in order to find the cosecant, it's 1 divided by the sine. So starting over here at 0, to find the cosecant, we need to do 1 divided by, and what's the sine? 0, and what's 1 divided by 0? Undefined. So we'll have a vertical asymptote at 0, as well as 2 pi. Now for pi over 4, this would be 1 divided by square root of 2 over 2. And what would that be? One divided by, oops, that's not a 1. 1 divided by square root of 2 over 2. And that's approximately what? 1.4. So that is about 1.4. This one would be 1 divided by 1, which would be 1. This would be 1 divided by square root of 2 over 2, which is 1.4. This would be 1 divided by 0, which is undefined. So we'll have another vertical asymptote at pi. This would be 1 divided by negative square root of 2 over 2, which would be negative 1.4. Same thing over here. This one is also negative 1.4. And this one would be 1 divided by negative 1, which is negative 1. So now the first thing we'll have to do is we need to draw in the vertical asymptotes wherever we see the word undefined. So our vertical asymptotes need to be at 0, pi, and 2 pi. So go ahead and draw in your vertical asymptotes at 0, pi, and 2 pi. Okay, now using those values we just got. For pi over 4, what was the cosecant for pi over 4? $1.4. What was the cosecant for pi over 2? 1. What was what's the cosecant for 3 pi over 4? 1.4. And between two vertical asymptotes, you'll either have a quadratic or a cubic. So what do we have here? Quadratic. So connect those points as a parabola, and make sure your parabola goes all the way to the top of the graph, and put arrows showing your parabola will keep going upward. Okay, so at 4 pi over 4, we have a vertical asymptote. And at 5 pi over 4, what did we say the cosecant was for 5 pi over 4? Negative 1.4. What was the cosecant for 3 pi over 2? Negative 1. And what was the cosecant for 7 pi over 4? Negative 1.4. And what shape would we have with those 3 points? Cubic or quadratic? Quadratic. But this one, instead of pointing upward, it points downward. So this one is concave down. And make sure that parabola goes all the way to the bottom of the graph and put arrows showing it will keep going upward. So that is one complete cycle of the cosecant parent function. So in order to have one complete cycle, you have to have two parabolas. One has to be concave up, the other one has to be concave down. And with the cosecant and secant parent function, it alternates. So this one is concave down, the next one needs to be concave up, the next one would be concave down, the next one would be concave up. So it alternates, up, down, up, down. Okay, so the period, how long did it take to make these two parabolas? Pi is just 1. So if I have to have both of them, it would be 2 pi. So the period for both sine and cosecant are both 2 pi. Now we need to complete one more cycle. So if I complete one more cycle using the same pattern, where would the other two vertical asymptotes have to be? Negative pi, and where else? Negative 2 pi. So if this one is concave up, the next one should be what? Concave down. And when we do the cosecant and secant parent functions, we normally just put that middle point and draw the parabola. And if that one is concave down, the next one should be what? Concave up. And that pattern would keep going on. So here, it keeps going left and keeps going right, but can we touch or cross those vertical asymptotes? No. So the domain would be all real numbers except where we have asymptotes. So all real numbers except x cannot equal. Now where is the first vertical asymptote? 0. And what do you have to add to 0 to get to the next asymptote? Pi. So if I just add pi, that'll only give me one asymptote. So I have to make it plus k pi, and then I have to find k and say where k is an element of the integer. So I can add pi and add pi and add pi, or if I subtract pi, that would get me to the next asymptote on the left side of 0. Now, is that in simplest form? No, why not? It has a 0. I just put that there so you can see the pattern of how to write the domain where you have the asymptote. So 0 was the starting asymptote, and we added k pi to get to the next one. But if I add 0, really, do I have to have that? No. So in simplest form, it's all real numbers except x cannot equal k pi, where k is an element of the integer. Now the range, we'll have to write this using two cases, because we need to write the range for the parabola that's concave up, as well as the interval for the range for the parabola that is concave down. So starting with the parabola that's concave up, where does it start? Where do the y values start? They start at 1 and go to the top would be infinity. And we are going to union that, so put the U for union. And we are going to union that with the range for the parabola that is concave down. And here, what's the top y value for this one? -1, and what's the bottom y value? Negative infinity. I have to be careful when I write that in integral notation. It's always the smallest number that goes first. So which number is smaller, -1 or negative infinity? Negative infinity is smaller, it needs to go first. So negative infinity, -1, and -1 is inclusive. Now something I'm going to point out about the cosecant parent function. I'm going to just sketch in what that sine parent function looks like. So for the sine parent function, it starts at 0, it goes up to 1, comes back down to 0, and it keeps coming back down to where it reaches the minimum at -1, comes back up to 0. So looking at that sine parent function that I kind of just drew on top of that graph, where do the vertical asymptotes fall on the sine function? Yeah, whenever the sine function is 0, you will have a vertical asymptote. So wherever that sine function touches the x-axis, the cosecant parent function will have a vertical asymptote. It will be on the side. And notice they share the same middle point, but this section of the sine parent function is concave down. It does the opposite. It's concave up. So they share the point, but if this is concave up on the sine function, for the cosecant parent function, it's concave down. So that's just extra for you to know. So make sure you start recognizing these patterns and what the parent functions look like. Okay, so after cosecant, the next one we have is secant. And secant is reciprocal for which one? Cosine. So to find the secant, we will do 1 divided by the cosine value. So 1 divided by cosine. Okay, so to find the secant, it's 1 divided by the cosine. So starting with 0, this would be 1 divided by 1, which would be 1. This one would be 1 divided by square root of 2 over 2, which is equal to 1.4. This one would be 1 divided by 0, which is undefined. This one would be what? Negative 1.4. This one would be what? This would be 1 divided by -1, which would be -1. And what would this one be? Negative 1.4. What would this one be? Undefined. And what would this one be? 1.4. Now, wherever you see undefined, we have to draw on the vertical asymptotes. We'll have vertical asymptotes at pi over 2 and 3 pi over 2. So draw on your vertical asymptotes. First, we'll have vertical asymptote at pi over 2, 3 pi over 2. And where would the next vertical asymptote have to be? Negative pi over 2. And one more. negative 3 pi over 2. Okay, let's start at negative pi over 4. So negative pi over 4 means we are rotating clockwise. So negative pi over 4 would be right here. And what is the secant value for negative pi over 4? 1.4. So negative pi over 4 is at 1.4. What about at 0? 1. And what about at pi over 4? 1.4. So here we have another parabola, and this one is concave up. Next one, 3 pi over 4. What is the secant for 3 pi over 4? Negative 1.4. And what is the secant for pi? Negative 1. And what is the secant for 5 pi over 4? Negative 1.4. And this one is concave down. And that is one complete cycle. So how many units did it take to make one complete cycle of the secant function? 2 pi. Okay, now, to complete the pattern, if this one is concave down, this one is concave up, what would the next one be? Concave down, so negative pi, put a point at negative 1, and that one needs to be concave down. And we don't have enough room to do another complete cycle, but if you still have room, you need to do a partial cycle. So this one is concave down, the next partial one should be concave up. So at negative 2 pi, put your point at 1. And we only have enough room to do one arm of the parabola. So put an arrow showing you a cube going to the left. So concave up, concave down, concave up, concave down. Over here we need one more, that would be concave up. So at 2 pi, put your point at 1. And we only have enough space to do the left arm of the parabola. And put an arrow showing you a cube going. Now the domain. We have some asymptotes, so we'll have to do some excluded values. So the domain would be all real numbers, except x cannot equal. And where's the first asymptote? I would do the positive one, pi over 2. But do I really know that's where it starts? You could find any, you could use any of these as a starting one. But I would just use pi over 2. I would use the asymptote that's closest to the origin, that's positive. But if I start at pi over 2, what do I have to add to get to 3 pi over 2? Pi, so plus k pi, where k is an element of the integer. And for the range, we have two parabolas, so we'll have to do a union of two intervals. And what is the range for the concave up parabola? 1 to positive infinity. Union that with concave down. And we already did this one. Negative infinity is the smaller one. Negative 1 is the larger one. So make sure for that second interval, negative infinity goes first because it's the smaller of the two. Questions on that one? Now this is really similar to what we saw with the sine function. If I just drew in the cosine function, right here is where the cosine function hits the x-axis, you have a vertical asymptote. Cosine keeps coming down, keeps going up. When it touches the x-axis, you'll have a vertical asymptote. and then the cosine function goes up to 1. So it starts at 1 and ends at 1. So anywhere that cosine parent function hits the x-axis, you will have a vertical asymptote, and you will have this shared point, and on the cosine function right here, it was concave up. So on the secant function, it's going to be concave down. So that's just extra information, maybe to help you. Okay, the final one, last one. Now we have the cotangent parent function. So if tangent is sine over cosine, how would you find the cotangent? Cosine over sine. So this would be cosine of x divided by sine of x. I'm going to go back to my unit circle. Okay, cosine divided by sine. Starting at 0. What's 1 divided by 0? Undefined. Cosine divided by sine. So this would be square root of 2 over 2 divided by square root of 2 over 2, which is 1. This would be 0 divided by 1, which is 0. This next one would be negative square root of 2 over 2 divided by square root of 2 over 2, which is negative 1. This one would be negative 1 divided by 0, which is undefined. And when I divide these two, what do I get? Positive 1. And cosine divided by sine. So 0 divided by negative 1 would be 0. And when I divide these two, I get negative 1. So wherever you see undefined, you need to draw in vertical asymptotes. So we need a vertical asymptote at 0, pi, and 2 pi. So vertical asymptote at 0, pi, and 2 pi. Okay, then plot your point for pi over 4. What was the cotangent for pi over 4? 1. Square root of 2 over 2 divided by square root of 2 over 2 is 1. What about the cotangent for pi over 2? 0. What about the cotangent for 3 pi over 4? Negative 1. So between the two vertical asymptotes, it's either quadratic or cubic. What's the case here? Cubic, but it's a negative cubic function. The left arm is pointing up, right arm is pointing down. So it's similar to the tangent function, but the left arm points up now and the right arm points up, right arm points down, and it's been translated. So there's one complete cycle. So how long is the period for the cotangent parent function? Pi. So tangent and cotangent both have a period of pi. Sine, cosine, and the reciprocals are all 2 pi. So it's just tangent and cotangent that are pi for the period length. Okay, now I need to complete more cycles. So mimic the same thing we did. So in the middle, that point is on the x-axis. Left arm is up. Right arm is down. And we'll have 2 more vertical asymptotes. And where are the other 2 vertical asymptotes? Negative pi and negative 2 pi. Go to the middle. That point needs to be on the x-axis. Find the middle. That point needs to be on the x-axis. Left arm is up, so the left point is up, and the right arm is down, so the right point is down. And make sure your cubic function goes all the way from the top of the graph to the bottom of the graph. Now, you don't have to go off the graph like I did, but make sure you go top to bottom. So we have asymptotes, so we'll have some excluded values. So our domain is all real numbers except x cannot equal. What's the starting asymptote? 0 plus, what do you add to 0 to get to the next one? K pi. Should I write it as 0 plus K pi? No, just leave it as x cannot equal K pi, where K is an element of the integer. And what's the range? All real numbers. Keeps going down, keeps going up. Make sure you memorize what these parent functions look like. You will have a quiz tomorrow where you will have to draw at least one of these. So make sure you know what a sine, cosine, tangent look like and what do the reciprocals look like.